So, continuing the previous lecture, entropy and the second law of thermodynamics. Um, we already did that thing, combining the first and second law expression. Uh, First law of thermodynamics for the control mass system, du was equal to dq minus dw. Putting dw is equal to pdv for the reversible process, for the quasi-equilibrium processes. Dq is equal to tds for the same reversible process. Substituting du is equal to du is equal to tds minus pdv. And now this equation, if you can imagine, like this equation is true for any reversible process, and for any reversible process the first law of thermodynamics can be written in this term as well. This equation, if you can imagine, it is actually more first law of thermodynamics, and when we define that thing, we did not define in terms of reversible or irreversible, and this equation is true for any of the processes, whether it is reversible or whether it is irreversible. So we have got the equation which is equal to du is equal to tds minus pdv. uh, the above equation is true because relation, now we have got the property which are now independent of the process. The equation which is du is equal to tds minus pdv is the combination of first and second law, and sometime it is, or it is called as the Gibbs equation as well. In terms of enthalpy, when we write the first law of thermodynamics, dh is equal to tds plus vdp. This is also the first law of equation in terms of the combining the second law as well. Now we have got a more another important, like most of the application, we are dealing with the ideal gas, we are dealing with the air and many other propulsion processes, aerodynamic application. We are dealing with the ideal gas, so we are looking at the equation of the first law, equation of the entropy in terms of equation of the entropy for the ideal gas. Du is equal to tds minus pdv. Du is equal to, sorry, so that means like du is equal to cv delta t. Putting that cv delta t in here and rearranging, that means like tds is equal to cv delta d. That means like du plus uh, w was there, cv delta t and pdv. uh, Taking this t at this side, so that means like that would be over t, and that being like t over here. So the equation would look something like this. So also pv is equal to rt, so that means like p by t is equal to r by v. Putting them over here, uh, so the equation would look something like this. Now integrating this equation from two different states, so that means like cv dt by t, that was up there, and plus r dv by v, going from v1 to v2 and from temperature t1 to t2. So we would be having the equation of the ideal gas with a constant specific heat, which is over here. For a non-dimensional, r by v is equal to gamma minus 1, cp by cv is equal to gamma. If you can imagine, that was something like this. So putting them over here, so in non-dimensional equation, your equation would look something like this. And for the specific quantity, just multiply with the number of moles, and that is over here multiplied with n. Now the expression gives entropy change in terms of temperature and volume. If you can look at the above equation, that give you the expression that is actually in terms of temperature and volume. Now, if you want to have an expression which is in terms of pressure and volume, just change the equation, and that is for the simple one. For the ideal gas, PV is equal to RT. You can look at this one. Taking log on both sides, so that means log of P plus log of V is equal to log of R plus log of T, and taking differential, dp by p plus dv by v is equal to dt by t. Now this dt by t can be replaced in this equation somewhere here, and that means like cv log of, and not log of, sorry for, because you will get the log later on, but yes, if you can just check, like, so you can put the dt by dt and just solving the equation, and you will get the equation something like this. I hope that you also understand the entropy change of the perfect gas, or also understand the second lecture. If there is any question related to it, please post it in the classroom. Thank you very much. Have a nice time.